On to page 2 of the acceleration equations. So there's two equations, v minus u over t, change in velocity over time, and v squared minus u squared equals 2 times a times s. On to the first one then. So we've got a car moving at a velocity of 30 metres per second, and then it brakes and stops in 10 seconds. We need to calculate the deceleration of the car. Now, because we said that the car stops, we know the end velocity is 0 and the start velocity is 30, so v equals 0, u equals 30, and the time taken is 10 seconds. And although it says deceleration, it's actually an acceleration that we're trying to find. So we need to choose our equation, and the one that links those together is v minus u divided by t. And now it's a case of substituting in the values. So 0, because it's the end, minus 30, the start, divided by 10. So our acceleration is actually minus 30 over 10, which then gives an answer of minus 3. But because the question asks for a deceleration and not an acceleration, it's actually slowing down, so it's a deceleration of 3 metres per second squared. On to the next one. We know it starts from rest and accelerates at 0.9 metres per second squared, and we need to calculate the velocity or final velocity after a distance of 12 metres. So again, we write down the values. We start at 0, so u equals 0, acceleration 0.9, and then for the next bit, we know that velocity is just v, that's the unknown, and we know we move a distance of 12 metres. There's no conversions, and again we need to use an equation that links all of those together. So it's not got time in, it's got a distance or displacement, so it's v squared minus u squared equals 2 times a times s. And now it really is a case of plugging in the numbers. So rather than v squared minus u squared, it's v squared minus 0, because 0 squared is 0, then 2 times 0.9 for acceleration, times by the distance, which was 12. I would then always simplify, so rather than 2 times 0.9 times 12, I'm going to simplify it, so the 0 disappears, and that then turns into 21.6. And then because it's still a v squared, we need to then square root it to get it v equals, so the square root of 21.6 works out at about 4.7, and then the unit metres per second. For the next one, we've got a cheetah, and it's sprinting at 8 metres per second, so that's going to be the starting speed. Accelerates at 4 metres per second squared over a distance of 30, and we need to calculate the final velocity. So another way of doing this is to write suvat down the side, where s is 30, u, we said, is 8, because that's the starting speed. We want to find the final velocity, so leave that as v. Acceleration is 4, and time, well, there's no time given, so we can just put a question mark or scrub it out. There are no conversions, so again, we need to choose the right equation. It's not got time in, so it's v squared minus u squared equals 2 times a times s. Like before, we put in the numbers where we can. So v squared stays that, because that's our unknown. And then u squared, well, that's 8 squared, so minus 8 squared. And that's then equal to 2 times 4 times by 30. And again, like before, we'll simplify. So v squared minus 8 squared, so that's v squared minus 64. And then the other side, 2 times 4 times 30, is then simplified to 240. We want v squared by itself, so we need to add 64 to both sides. So v squared is 306. We need to square root v squared to get v by itself. So the square root of 306 works out in a calculator to be around 17.5. And again, the units for velocity are metres per second. For the next one, we've got an aeroplane travelling at 25 metres per second, accelerating at 3, and we want to find the final velocity after 100 metres. So again, we can write down what we know. So u25, our starting speed, acceleration we said was 3, we're trying to find v, and the distance is 100. Again, like before, it's not got time in, so we need to use v squared minus u squared equals 2 times a times s. Simplify by putting in the numbers, so v squared minus 25 squared, and then 2 times 3 times 100, we can then simplify to 600. So v squared minus 625 equals 600. Then move the 625 to the other side, so that then means v squared is 1225. Square root that to get v by itself, so the velocity works out to be roughly 35 and then metres per second. Our large boat, so we're expecting it to be a small acceleration that we're trying to calculate, because it moves from 0.2 to 1.6 over 1.2 kilometres. So u equals 0.2, v equals 1.6, and then the first thing to do is to convert. So our first conversion here, 1.2 kilometres is 1,200 metres. So again, no time, so v squared minus u squared equals 2 times a times s, and like before, put in the numbers. So 1.6 squared minus 0.2 squared equals 2 times a times by 1,200 from the conversion. So again, we simplify, so 1.6 squared is 2.56, and then take away 0.2 squared, which is 0.04, and that's then equal to 2,400, 2 times the 1,200, and then the a remains, so multiplied by a. And then onto the final stretch, let's simplify it some more. So 2.52 equals 2,400 times a, so a equals 2.52, and then that's then divided by 2,400. So we get a really small acceleration, which works out to be 0.01, sorry, 0.001, and then meters per second squared. And then finally, we have our object in space. So that's then travelling at 2 kilometers per second. So I'm just going to put that in straight away. That's 2,000 meters every second as our starting velocity. We're trying to find the final velocity. The acceleration is 1.5 meters per second squared. And then it's 100 kilometers, so that's 100,000 meters. So we've done the conversions, but again, no time. So it's v squared minus u squared equals 2 times a times s. So v squared, and then that's minus 2,000 squared, which is 4 million. And that then equals 2 times 1.5 multiplied by 100,000. Again, we can simplify. So v squared, and then take away that 4 million is then equal to 300,000. So rearrange. So then we need to add them together. So then v squared equals 4.3 million. And then the final thing to do, of course, is to get v squared into v. So we need to square root that whole amount. So v, as the final answer, equals roughly 2074 meters per second.